Okay? 3.3 talks about linear equations in two variables. Linear equations in two variables. How many variables do you expect to see? Two, yes. We want to be able to identify linear equations in two variables. We want to talk about intercepts of the coordinate axes. We want to learn about horizontal and vertical lines. Okay? So let's start out with the definition. A linear equation in two variables, say x and y, is an equation that can be, good morning, is an equation that can be written in the form ax plus by equals c, where a, b, and c are constants, and a and b are not both zero. This form of an equation like this is called standard form. So, the takeaway from this definition, the standard form of a linear equation in two variables is given by ax plus by equals c, where a and b are not zero, and they're constants or numbers, and c is a constant or a number. Okay? Okay? Oh, my word. Okay? All right. So now what we're going to do in example 1, we're going to determine if the following equations are linear. So in other words, we want to see if we can write our equations in this form ultimately. You with me? Yes? No? Okay. So what should we do first? Yes, distribute. I'm with it. Tell me what we write. Talk loud, please.
Plus 4y
Mm-hmm.
minus 4x.
Yes, good. Someone else pick it up from there.
9x minus 4x is 5x.
Bless you. So 5x
Plus 4y
mm-hmm.
equals 3.
equals 3. Good. Do we need to do anything else? Can't hear you?
We're just getting in the ax plus by equals c form.
That's right. We're just getting it in this form if it's possible. So what can you conclude here? That it is what? It's in the same form, so we can conclude it's linear, right? So the answer here would be yes. It said determine if the following equations are linear. So the answer here is yes. The answer here is yes. What questions do you have? Okay. Yes. What are our two variables here? X and Y. Yes, that's absolutely correct. So I'll highlight the X and the Y to show you where those two variables were.
So when it was like 5x equals 3, that would not be the answer.
It would, so that's a tricky one, right? So if you have 5x equals 3, so let's change it. So this is for the sake of conversation, right? If you have 5, that's a highlighter. So if we have, so an aside because there was a question. If you have 5x equals 3, that really means x is equal to what? What is it? 3/5, yeah? Good, right? So if we wanted to graph that, if we wanted to graph x equals 3/5, we go over to 3/5. So if this is 1, 3/5 is, say, right here. We go here. And this line would be x equals 3/5. Is it a line?
Yeah.
Yes, it's just what kind of line?
Vertical.
It's a vertical line, yeah? And so you can really think of this as we can go back to this line or to this equation here, And I'll highlight this to show you that, just open it. The slow opening is a little distracting. Just open it. It's okay. Yeah, no problem. So you can really think of that as 5x plus 0y equals 3. So because we can think of this y part as with the 0 in front of it, because it's really 0, then yes, this would still be a line. It's just a vertical line. Does that make sense? What questions do you have? So vertical lines are lines. Yes, they're just in the form of x equals a number. Are we okay? All right. Talk a little louder.
What is it saying if it was like 4y equals 3? Or you're saying
What kind of line is that though?
horizontal?
That's right. So she said if we have 4y, different color, different, we're answering another question. If you have 4y equals what? 3. If you have 4y equals 3, you can think of this as 0x plus 4y equals 3. And because you'll get y equals 3/4, that is a horizontal line. We can label our axes. Horizontal line going through 3/4. That's y equals 3/4. So yes. Does that make sense? Yes, no? All right. What questions do you have? You need me to leave it here for a second, or are you good? That's a question. Good? Okay. All right. So more examples. B. We have 3x plus xy equals 2y. Is that a line?
No.
No, absolutely not. You are correct. No. Why? Why is it not a line? Because there's an xy. You got it. Because the equation has, quote unquote, the xy in it, right? So we know in the back of our minds that we should be trying to see if we can write the equation in this form. That's what we're keeping in mind, that highlighted part. So that's impossible with part B. And part C, is this a line? No, it's not. It is not. It's not a line. Now, you might have to do a little bit more work to see why it's not a line. But I agree with you. Overall, no, it is not. We have to figure out why though. Okay? So, because this is a x plus y quantity squared minus a x minus y quantity squared equals 1, we're going to expand this left side to see what we have. Okay? So it's a little bit more involved for this one. I do agree that it's no. Let's find out why. We okay? All right. So let's expand. So whenever we expand the left-hand side, you have x plus y times x plus y minus x minus y times x minus y. That's equal to 1. And so then we use the FOIL method here and then here. But here, when we use a FOIL method, we end up with x squared plus what? xy plus xy plus, good. And then minus, but we're going to be subtracting a whole lot. So we're going to put that in parentheses because when you use the FOIL method here, you got to remember to distribute. So we're going to hold off distributing. I just want you to tell me what it's going to be when you use the FOIL method. Go.
X squared
Yes.
minus yx
Yes.
minus yx
Yes.
plus plus y squared.
Yes. Good. All of that equals 1. So now we should distribute this negative to each part in parentheses. So red to illustrate, we're going to do this in the next step. We're going to distribute the negative to each part. So when we do that, we write down what we have first, x squared. Xy plus xy is 2xy, good. Plus, yes. And then tell me what's the rest now. Minus x squared. Plus 2yx. Where did that come from? Oh, yeah. We distributed the negative here. Yeah. And whenever you did it here, 2yx, right? That was a negative 2yx, but you distributed the negative. It became a positive. Very good. And so negative y squared. Good morning. 9:30.
That's the time I fell asleep.
9:30 is the time you got to be here. You can do it. Okay? You got this. Equals what? Equals 1. Yeah? Okay, so now what happens? Combine like terms? What happens? Oh, the x squares cancel out. You said the y squares cancel out. Yes. Say what? What's 2xy plus 2yx? It's not, or it is? You multiplying. Say what? Are they the same or not? No? Oh, so let me ask you this. So let me ask you this. If I give you 2 times 4 times 3 and then I ask you what's 2 times 3 times 4, are they different? So they the same? So you get the same answer? Yeah? So if we multiplying 2 times x times y, and we're adding to that 2 times y times x, are these different or are they the same? Oh, okay. So they the same. Yeah. So can you add them? And if you can, what do you get? 4xy. Yeah, that's right. So you get 4xy equals what? 1. And what does that say about our overall question? It's not linear, right? It's not a line. Why? It's not a line because it has what? It has an xy. Yup. You're right. So no, because the equation has xy. So far we've talked about lines. We did a quick recap of what to expect for next week. Okay? I'll pause this and go back so you can take pictures of it. You want to take pictures of it? Okay. Part D. Part D, we have x minus 3 equals 4x plus 17 over 5. Does this look like a line? No. But are you confident it's not a line? No. So what can we do? We can solve. We can figure it out. Yeah? You want a minute? You want a minute? I'll give you a minute. Go ahead.
Okay, so.
You recording? Yeah.
Yes. Damn, I gotta talk through it.
Yeah.
Okay, so. So you multiply everything by 5, right? Okay.
Feel like I'm in church. Why can't y'all give me this when I ask y'all questions? I want that encouragement too.
Okay. Don't mind my handwriting. It's too early for this. Oh yeah, I'm tripping. Yeah, and then you take.
More room, just pinch out, grab this. Yeah.
Then you
Like
take away 4x. don't know why I put plus 17 like that, but
So you can erase it if you want to. Write whatever you want. Alright.
then add 15. Then you
Push it out
get,
so you can see the top part too. Yeah, good.
and then you get is that right? Oh, and it is a line because like x is a line. Is that like an axis, right? It's an axis. So if it's not
Can you
too
sketch a graph?
uh
Yeah. Is it horizontal?
oh, I'm tripping.
Is it horizontal?
Yes. Is it? Wait.
Is x equals a number?
No, it's
or
vertical. It's
horizontal?
vertical. It's vertical.
That's right. What is it
It's
gonna go
vertical.
through?
The x-axis.
Yeah, and so then you draw your arrows, right? Class, y'all supposed to be helping.
Oh, yeah.
Like this.
Uh-huh.
Okay. And now I don't know what to do because.
Is there anything else to do?
Oh.
Yeah,
Oh.
underneath that line, you write what? What's that? What you write? Oh, you signing it and things?
No, I'll try to write yes.
Oh, listen, I can't read.
My handwriting messed up early in the
I didn't know
morning.
what it was. What should you write under the line that you drew though?
X equals 32.
Oh, yeah.
Underneath it.
Okay. Like that.
What questions do you have?
We have no questions.
So what do we do? No, be careful.
I didn't see that chair.
Be careful. Good job. So you still get a line, but it's what kind of line? It's a vertical line. You got it. Very good. Very good. It's good stuff. So yes, this is a line. So we're good. What questions do you have? All right. Good. So let's talk about a little bit more. Let's go over some more definitions here. Any point where the graph intersects the x-axis is called an x-intercept. It's called an x-intercept. And these are of the form parentheses c comma 0. So notice that the y coordinate is 0. So picture-wise, what you're visualizing is the coordinate plane. And if your graph intersects the x-axis, like the example that Kevin just did, right? If it intersects here, then this point right here, that's your x-intercept. And particularly, it will be given by 32 comma 0, as in that previous example, right? That would be the x-intercept. Now, no surprise, any point where the graph intersects the y-axis is called a right. It's called a y-intercept. And these are of the form 0 comma c. Notice that the x coordinate here is 0 for the y-intercept. That's no surprise. It has to be for the y-intercept. Okay, so here, visually, what that would look like is it's crossing here, right? And that would be your x is 0, so 0 comma c, if that's c. Okay? So now what we're going to do is we're going to find the x and the y-intercepts of the given equations, and we're going to sketch the graphs. I'm going to sketch the graphs. I see some writing. Do you need a second? Okay. Example 2. Before we begin, if we're finding the x-intercept, we know the y-coordinate is 0. Good. If we're finding the y-intercept, what do we know? The x-coordinate is 0, yes? So if with what we have to do in this equation, or with example 2, we need to find the x and the y intercepts of the given equations. We know to find our x-intercept, we set y equal to 0. Good. To find our y-intercept, we set x equal to 0. Yes. And then we can go through and sketch the graph. Okay. So I'm just going to make a table because it's visually pleasing. So we first want to find our x-intercept. So in parentheses, I'm going to put we need to set y equal to 0 because that's what we said we need to do. And we're going to find that. But then on the other side, we're going to find our y-intercept, which means we need to set x equal to 0. Yeah? Now, that's only the first part of the problem because the second part says we need to do what? Graph it, right? Okay. So graph what? Say what?
The X and Y intercepts.
Do we need to graph the x and y intercept?
I think it's only like one coordinate, yeah? Are you gonna put it together after you finish solving it?
That's what I'm asking.
Yeah, then that.
We're going to graph the x-intercept and the y-intercept? Or one coordinate?
One coordinate.
One coordinate? Does everyone agree?
Yes.
I heard some say yes, some say no. What? So,
We're solving for X and Y, put them together.
so we're solving for the x-intercept, which is going to give us how many coordinates? 1, yes. And when we solve for the y-intercept, we're going to get 1 coordinate. So we should be able to plot 2, right? Does that make sense? Okay, so when we plot those 2, we should be able to connect it and get a line if it's a line. Yeah? Because we need 2 points to graph a line. Does that make sense?
Yes.
All right, so our x-intercept, we need to set y equal to 0. Let's highlight what we're going to use. So we set what equal to 0, we said? Y. So tell me what we write.
0 minus 3x equals 9.
Yes. Then,
Negative 3x equals 9.
yes.
Divided by negative 3.
Then we divide both sides by negative 3. And someone pick it up from there. Good.
X equals 7.
No, someone else pick it up. What do we do? X equals negative 3. Good. Both of y'all out. X equals negative 3. So what's the coordinate pair? What's the order pair? 0. Good. You're out.
Are you divided by 3?
We divided by negative 3 here because we were solving for x. So let's recap. Are we okay that we put 0 in for y? So that gave us 0 minus 3x equals 9. That gave us negative 3x equals 9. Are we okay? And then we divided both sides by negative 3 because we wanted to solve for x. So then we get x equals negative 3. So then remember our ordered pair, or our new word, x-intercept, is given by negative 3 comma 0. Because we found out x was negative 3 and we know y is 0. Does that make sense? Okay, so if you want to go ahead and plot that, go ahead and plot it, right? You can do that. Tell me how to get there from the origin. Oh, don't yawn. What do we do?
Go left 3.
Go left 3. You telling me I'm boring? I don't like that.
No, that's not that, I promise.
Okay. So we get negative 3 comma 0. Are we good there? No? Did someone say no? If you said no, tell me why. Yeah, because we have to graph y. We have to find our y-intercept, yeah? So we find our y-intercept. We said x equals 0. Tell me what we write.
Y minus 3.
You're out. If you talk, you're out. Y minus equals what? 9. Good. You're out. So then what do we do? Say what? Y equals 9? Yes. Good. You're out. 2 of you said that. You're both out. Yeah. Your y equals 9. Okay, someone who hasn't answered. Tell me what our ordered pair is. 0, 9. Good, you're out. You're out. 0, 9. Tell me how we get to 0, 9 from the origin. Go up to 9, yeah. So now we got our 2 points. What do we do? Connect them. Y'all know how my sketches are, but go with it. See, I didn't even go through the point, but yeah. Listen.
It's all right.
We get it, right? Don't talk about my graphs. It's a what?
It's a line.
It's a line. It's a line. Excellent.
It do look like a line.
It is, because I did a great graph. Yes.
What does it look like if it's not a line?
That's a good question. What does it look like if it's not a line? An example, you can have a circle, right? Think about 3.2. Think about 3.2. The general equation means we were able to have a center, we were able to have the radius, and that would be something that is not a line. It's a great question. Okay, what other questions do you have? Yes?
When do we determine that line x equals 0?
You said when do we, say it again?
When do we determine that line x equals 0?
Ah, that's good because the definition, the question was when do we determine how x and y is 0? That was a question, right? So it comes from here in our definition. So if we're finding our x-intercept, we know that the point should look like this. And when the point should look like this, that means that y is 0. That means that y is 0. You weren't the only one with that question. So thank you for asking. So whenever you're finding your y-intercept, notice that it's in the form 0, c. That means x equals 0. So for the y-intercept, we need to set, or for the y-intercept, we need to set x equal to 0. For the x-intercept, we need to set y equal to 0. Good question. What other questions do you have? Okay. All right. So part B. Part B. Part B, we have y minus 2x equals y minus 4. We have y minus 2x equals y minus 4. So, what are our instructions? Yep, good, both of you. You find the x and y intercepts and then you sketch the graph. You want to try it? You want to try it? Raise your hand if you want to try it. A few? I'll give you a chance to try it.
Yeah, the Y is just really funny.
Finding the y-intercept was funny. It was weird. Why was that?
Because our Y's cancel out.
The y's canceled, right? The y's canceled. That's right. So let's write this out because you started out with that. So first you said you want to find the y-intercept. So you had what equal to 0? So when you did that, you get y minus 2 times 0 equals y minus 4. And then what do we get?
Y equals Y minus 4.
Yes, and then what do you do?
You gotta take the Y from the right out.
Good. Both of y'all are right.
So it'll be 0 equals -4, which isn't correct.
0 equals -4 isn't correct. It's a false statement, right? 0 and -4 are not the same. There's no y-intercept. So it seems a little weird and it seems a little funny, but the algebra tells us that because we ended up with a false statement, that it's not possible for us to have a y-intercept. So no y-intercept. That's all we get from that part. Does that make sense?
Yes.
Okay. And so then we go to our what? X-intercept. Good. So we have to set y equals 0. Good. Good to get negative 2x equals. Yeah. Yeah. And then someone else tell me, so good. And then someone else tell me, what do we get for our ordered pair? 2, 0 like that? Oh, parentheses, yes. And then, because we ended up with the x-intercept, what do we know about our graph? It's a what? I heard it's vertical. I heard it's not a line. What is it? Oh, it's a vertical line going through what? X-axis, and what on the x-axis? Oh, you're good at describing things. Yes. So you get x equals 2. And if you want to plot that, you get this. Yeah, good job. Excellent work. Excellent work. Y'all don't applaud for me when I write up something right. Thank you so much. Thank you so much. Yes? All right. Okay. So, horizontal lines. So a few facts. I want you to be able to walk away from this. A few facts. We talked about them already, but just so you actually have this to work with. Horizontal lines are of the form y equals a number. So whenever we're talking about horizontal lines, we know it is y equals a number where a is a constant. So here we have y equals 2. We know it's a horizontal line going through 2 on the y-axis. So this is y equals 2. Does that make sense? Okay. Vertical lines have what form? X equals a. Good. X equals a. Where a is a constant or number. So here we have x equals -1. On the graph, what do? Tell me how to get there from here. Go to the left one and then make it vertical. Yeah. That's vertical. X equals -1. Good. What questions do you have? What questions do you have? None? Okay. It's 10:32. Let's keep rolling. You said, am I sure? What questions do you have? What questions do you have?